The universe is hiding something from us. 7 mysteries we still can't explain. Imagine traveling farther than any human spacecraft could ever reach. Past the planets, past the stars, past entire galaxies. Eventually, you would reach a place where there is almost nothing. No sound, no familiar landmarks, only darkness and billions upon billions of distant stars. But here's the terrifying part. The farther we look into the universe, the more mysterious it becomes. We have discovered galaxies billions of light years away. We have detected black holes that bend space and time. We know the universe is expanding. And yet, some of the biggest questions remain unanswered. What is most of the universe actually made of? What existed before the beginning? Are we truly alone? And perhaps the strangest question of all, why does the universe exist in the first place? Mystery number 1, the invisible universe. Imagine looking into the night sky. You see stars, you see planets, you see enormous galaxies containing billions of suns. Everything appears to be there. But scientists believe something enormous is missing from what we can see. Something invisible. Something that does not shine, something that does not appear in ordinary telescopes. And yet, it may make up most of the matter in the universe. Scientists call it dark matter. We don't know exactly what dark matter is, but we know something strange is happening. When astronomers observe galaxies, they discover that stars near the edges of galaxies are moving far faster than they should. According to the amount of visible matter stars, gas, and dust, there shouldn't be enough gravity to hold those galaxies together. The galaxies should slowly tear themselves apart, but they don't. Something unseen appears to be providing additional gravity. Imagine throwing a ball around a massive object. The stronger the object's gravity, the faster the ball can orbit without escaping. Now imagine looking at a galaxy and discovering that its outer stars are moving much faster than the visible matter should allow. It's as if the galaxy contains an enormous invisible mass surrounding it. And that is where the mystery begins. Scientists think galaxies may be surrounded by enormous halos of dark matter. These halos could extend far beyond the visible regions of galaxies. We cannot see the halos directly, but we can see their gravitational effects. It's similar to watching leaves move in the wind. You cannot see the wind itself, but you know something is there because of what it does. Dark matter may be like that, invisible, but powerful. And this changes the way we think about the universe. The stars, planets, and everything we can see may represent only a small fraction of what actually exists. The universe could be filled with an invisible structure connecting and surrounding galaxies. But there is an even stranger question. What is dark matter made of? Scientists have proposed many possibilities. Maybe it consists of particles that barely interact with ordinary matter. Maybe there are particles we have never discovered. Maybe our understanding of gravity is incomplete. For decades, researchers have built enormous underground detectors designed to catch the rare interaction of dark matter particles. So far, the mystery remains. We still haven't directly identified the substance responsible, and that means something extraordinary may be true. We have mapped enormous portions of the observable universe, yet we may not actually understand what most of its matter is. Think about that. Humanity has sent spacecraft to other planets. We've photographed black holes. We've detected gravitational waves from collisions between massive objects. We've measured the afterglow of the early universe, and still, one of the most important substances in the cosmos remains invisible to us. Perhaps one day, a detector will finally record the unmistakable signature of a dark matter particle. If that happens, it could transform our understanding of physics. But until then, the universe keeps its secret. Because when we look into the darkness between the stars, we may not be looking at empty space. We may be looking at something that is everywhere, something enormous, something invisible, something that could be shaping the entire universe, while remaining completely hidden from our eyes. Mystery number 2. The force that is tearing the universe apart. For thousands of years, humans looked at the night sky and imagined an unchanging universe. The stars appeared fixed. The galaxies seemed to simply exist in an enormous, silent space. But in the 20th century, scientists discovered something that completely changed our understanding of reality. The universe is expanding. Galaxies are moving away from one another as space itself expands. At first, this wasn't completely unexpected. Scientists imagined that gravity should eventually slow the expansion down. After all, gravity pulls matter together. The universe began in an extremely hot and dense state, and ever since then, space has been expanding. So scientists expected that gravity would gradually weaken that expansion. But then came a shocking discovery. The expansion of the universe wasn't slowing down. It was accelerating. Something seemed to be pushing the universe apart. Scientists gave this mysterious phenomenon a name: dark energy. But the name makes it sound as though we understand it. We don't. In fact, dark energy may be one of the greatest mysteries in modern physics. Scientists estimate that roughly 68% of the universe is dark energy. That means the substance or phenomenon responsible for accelerating cosmic expansion could make up more of the universe than everything else combined. And yet, we don't know exactly what it is. Think about how strange that is. Everything you've ever seen with your eyes, the Earth, the Moon, the Sun, stars, galaxies, planets, represents only a tiny portion of the cosmic picture. Most of the universe may be dominated by something we cannot directly see. But how did scientists discover that something was accelerating the universe? One important clue came from distant exploding stars called Type Ia supernova. These explosions are incredibly bright and can be used by astronomers as cosmic distance markers. By studying how bright these explosions appear, and comparing that with how their light has been stretched by cosmic expansion, scientists can estimate how the universe expanded over time, and the results revealed something unexpected. Billions of years ago, the universe's expansion was slowing down. But later, something changed. The expansion began accelerating. It was as if the universe reached a point where gravity was no longer winning. Something else had taken control, and scientists still don't know what. One possibility is that empty space itself contains energy. Even what appears to be a perfect vacuum may not truly be empty. Space could possess an intrinsic energy that causes the universe to expand faster and faster. Another possibility is that our understanding of gravity is incomplete on the largest scales. Maybe Einstein's theory works extraordinarily well, but something about gravity changes across enormous cosmic distances. And there is an even more disturbing possibility. Perhaps dark energy isn't constant. Perhaps it changes over time. If that were true, the ultimate fate of the universe could be very different from what we currently expect. One possible future is known as the Big Freeze. If expansion continues accelerating, galaxies outside our local cosmic neighborhood will eventually move so far away that their light will never reach us. The universe could become colder, darker, and increasingly empty. Stars would eventually stop forming. Existing stars would burn out. And over unimaginably long periods of time, the universe could approach a cold, dark state. But we don't know if that is exactly how the story ends, because we still don't understand the mysterious force driving the expansion. Dark energy is not just a strange detail about the universe. It may determine the ultimate destiny of everything that exists. And perhaps the most unsettling thought is this: we can see the universe expanding. We can measure its acceleration. We can calculate its effects, but we still don't know what is causing it. Something appears to be pushing the universe apart, and whatever that something is, it may control the future of the entire cosmos. The universe is not simply expanding, it is accelerating into the unknown. Mystery number 3, the Great Silence. Are we alone? The universe is unimaginably large. There are hundreds of billions of galaxies in the observable universe. Inside those galaxies are hundreds of billions of stars, and around many of those stars are planets. Some may even have the right conditions for life. So there is a question that has haunted humanity for generations. If life can exist here, why haven't we found it anywhere else? This is known as the Fermi paradox. The basic problem is surprisingly simple. The universe has existed for roughly 13.8 billion years. Earth is only about 4.5 billion years old. That means there were billions of years before humanity ever appeared. During that enormous period of time, intelligent civilizations could theoretically have evolved somewhere else. And if even one of those civilizations became technologically advanced enough, it might have had millions or even billions of years to spread throughout its galaxy. Yet when we look into space, we hear almost nothing. No confirmed alien messages, no unmistakable artificial signals, no evidence of an extraterrestrial civilization, just silence. But perhaps the silence doesn't mean we're alone. Maybe we're simply listening in the wrong way. Imagine an ant colony trying to detect human civilization. The ants might live beneath a city filled with radio towers, satellites, airplanes, computers, and millions of people. But the ants would have almost no idea what any of it means. An advanced civilization millions of years ahead of us could be equally difficult to recognize. Maybe aliens don't communicate using radio waves. Maybe aliens don't communicate using radio waves. Maybe their technology is beyond anything we can imagine. Or perhaps intelligent civilizations don't remain technologically active for very long. This leads to one of the darkest possibilities connected to the Fermi paradox, the Great Filter. The Great Filter is a hypothetical stage in the development of life that is extremely difficult to pass. It could occur very early. Perhaps the transition from simple chemistry to life is extraordinarily rare. Maybe the development of complex cells is incredibly unlikely. Maybe intelligent life almost never evolves. Or perhaps the dangerous filter comes later. Maybe civilizations eventually develop technologies powerful enough to destroy themselves. If that's true, the silence of the universe could have a terrifying explanation. Civilizations may appear, develop intelligence, build advanced technology, and then disappear before they can communicate across the stars. But there is another possibility. Maybe the universe is simply too vast. The nearest potentially habitable worlds could be many light years away. Even traveling at speeds far beyond our current spacecraft, reaching another star could take generations, and communication is limited by the speed of light. A message sent to a civilization hundreds of light years away could take hundreds of years just to arrive. The reply could take hundreds more. Two civilizations could exist at the same time, and still completely miss one another. There is also something important to remember. Humanity has only been searching for technological signs of extraterrestrial life for a tiny fraction of cosmic history. Our radio technology is barely a century old. On the cosmic calendar, that is almost nothing. We may have entered the conversation, but perhaps we have only just started listening. And maybe somewhere, around a distant star, another civilization is doing exactly the same thing. Looking into the darkness, wondering if anyone else exists. Listening for a signal, waiting for an answer. So perhaps the greatest mystery isn't whether aliens exist. The greater mystery may be, if they are out there, why haven't our paths crossed yet? Maybe the universe is empty. Maybe intelligent life is incredibly rare. Maybe civilizations are hiding. Or maybe, somewhere beyond the stars we can see, someone is already listening, and just like us, they are waiting for the silence to break. Mystery number 4. What happened before the Big Bang? Imagine going backward in time. Past the first humans, past the dinosaurs, past the formation of Earth, past the birth of the sun, past the first stars. Keep going until you reach the beginning of the universe. But then you face a problem. What was there before the beginning? According to our best current model, the universe began about 13.8 billion years ago in an extremely hot, dense state and has been expanding ever since. This event is commonly called the Big Bang, but the name can be misleading. The Big Bang wasn't simply an explosion happening at one location in empty space. Instead, space itself was expanding. Every region of the universe was once much hotter and denser than it is today. And if we mathematically trace that expansion backward, we eventually reach a point where our current theories stop working. This creates one of the deepest mysteries in cosmology. Was there actually a beginning? Or did something exist before the Big Bang? The problem is that our understanding of physics breaks down under the extreme conditions of the earliest universe. Einstein's theory of general relativity describes gravity and the structure of space-time extraordinarily well. Quantum mechanics describes the strange behavior of matter and energy at tiny scales. But near the earliest moments of the universe, we need both theories at the same time, and they don't fit together completely. Scientists therefore don't yet have a complete theory of quantum gravity. Without one, we cannot confidently describe what happened at the ultimate beginning. And there's an even stranger possibility. Maybe the word before doesn't even make sense. Time itself is part of the universe. If time began with the universe, asking what happened before the Big Bang could be like asking what's north of the North Pole. The question sounds reasonable, but perhaps there is no location beyond the boundary. However, scientists have proposed other possibilities. One idea is that our universe could have emerged from an earlier universe. Perhaps the universe goes through cycles of expansion and contraction. A previous universe collapses, and somehow a new universe begins. Another possibility is that our universe is part of a much larger reality, containing many universes. In some versions of this idea, our Big Bang could represent the birth of only one region of a much larger cosmic structure. There are also theories involving quantum fluctuations, cosmic bounces, and other mechanisms that attempt to explain how a universe could emerge without requiring a traditional beginning. But none of these ideas has been confirmed as the answer. And this is where the mystery becomes truly profound. When we look into space, we are also looking into the past. The farther away an object is, the longer its light has traveled to reach us. When we observe distant galaxies, we are seeing them as they existed billions of years ago. And when scientists study the cosmic microwave background, the faint radiation left over from the early universe, they are observing an ancient snapshot of the cosmos. It is the oldest light we can directly observe. But even that light doesn't take us all the way to the beginning. There is a barrier. Before the universe became transparent, light could not travel freely through space. So there is a limit to how far back ordinary light can show us. Beyond that boundary, the universe becomes hidden behind the conditions of its earliest moments. It's almost as if the cosmos has drawn a curtain across its own beginning. And perhaps the greatest question is not simply what happened before the Big Bang. It is this: why did the universe begin at all? Why is there something rather than nothing? Why do the laws of physics exist? Why does space exist? Why does time exist? And why does a universe capable of producing stars, planets, life, and consciousness exist in the first place? We can trace the universe backward billions of years, We can study its earliest visible light. We can build mathematical models of its birth. But eventually, we reach a boundary where our knowledge ends. Beyond that boundary, there may be an answer waiting. Or perhaps there is no before. Perhaps the beginning of the universe was also the beginning of time itself. And if that is true, then the universe didn't begin inside time. Time began with the universe. And that means the ultimate beginning may be something our human minds were never designed to fully understand. Mystery number 5, the black hole that may break the laws of physics. Here are places in the universe where gravity becomes so powerful that nothing can escape. Not a spaceship, not a planet, not even light. These objects are called black holes. But black holes aren't simply giant cosmic vacuum cleaners. They are regions of space-time where matter has been compressed to extraordinary densities, creating gravity so strong that beyond a boundary called the event horizon, escape becomes impossible. And this creates a terrifying question. What happens to everything that falls into a black hole? Imagine throwing a book into one. The book contains information. Every word, every letter, every page. From our perspective, once the book crosses the event horizon, we can never retrieve it. It seems to disappear permanently. But quantum mechanics says something extremely important. Information should not simply disappear. And this creates one of the greatest problems in modern physics. The black hole information paradox. To understand the problem, we need to look at something predicted by Stephen Hawking. In the 1970s, Hawking showed that black holes are not completely black. Because of quantum effects, near the event horizon, black holes can slowly emit radiation. This became known as Hawking radiation, and it leads to a remarkable possibility. Black holes may eventually lose their mass. Over incredibly long periods of time, they could shrink. And eventually, in the simplest picture, they could disappear completely. The black hole information paradox has troubled physicists for decades. Perhaps the information is encoded in the radiation emitted by the black hole. Perhaps the event horizon somehow stores information. Perhaps information is connected to the surface area of the black hole itself. Or perhaps our current understanding of gravity and quantum mechanics is incomplete. One of the most fascinating ideas is related to the holographic principle. The basic idea suggests that information describing a region of space might somehow be encoded on its boundary. In other words, the information inside a volume could potentially be represented by information on a lower dimensional surface. It sounds almost like science fiction. But this idea emerged from serious attempts to understand black holes and quantum gravity. And it raises a breathtaking possibility. Maybe the universe doesn't work quite the way our everyday experience suggests. Maybe information about objects that fall into black holes isn't destroyed. Maybe it is transformed. Maybe it is somehow preserved on the boundary of space-time. But we still don't have a complete answer. And this mystery is important because black holes may be more than strange objects floating in space. They could be laboratories for discovering the deepest laws of reality. General relativity tells us how gravity shapes space-time. Quantum mechanics tells us how nature behaves at microscopic scales. Black holes force these two descriptions into the same extreme environment. And that's where our theories begin to struggle. Some physicists believe solving the black hole information paradox could help reveal a deeper theory that unifies gravity and quantum mechanics. A theory that could explain what space-time itself is made of. That is why black holes are so important. They are not merely cosmic monsters. They may be clues. Clues pointing toward a deeper structure beneath everything we know. And perhaps the strangest part is this. A black hole may eventually disappear. But if the laws of quantum mechanics are correct, the information about everything that fell into it must somehow remain. The universe may allow matter to vanish from our view. It may allow stars to collapse. It may allow entire worlds to disappear beyond an event horizon, but perhaps it does not allow information itself to be destroyed. And if that's true, then somewhere in the darkness of a black hole, the history of everything that entered it may still exist, hidden, transformed, waiting for us to understand how to read it. Mystery number 6. The universe has a shape, but what is it? When you look into the night sky, the universe appears to stretch endlessly in every direction, up, down, left, right. As far as your eyes can see, there are stars and galaxies. But here is a strange question. What is the shape of the universe itself? Not the shape of a galaxy, not the shape of a planet, the shape of space itself. It may sound like a simple question, but scientists still don't know the complete answer. To understand why, imagine living on the surface of Earth. If you were an ant walking across the planet, the ground beneath you would appear flat. You could walk in a straight line for a very long time without noticing that Earth is curved. But if you continued long enough, you could eventually return to where you started. The surface of Earth is curved in a higher dimensional space. Now imagine something similar happening with the universe. Space itself could have a geometry that isn't obvious from our local perspective. There are 3 broad possibilities. The universe could be flat. It could have positive curvature, somewhat like the surface of a sphere. Or it could have negative curvature, somewhat like a saddle. And this isn't just a philosophical question. The geometry of the universe is connected to its contents and its ultimate behavior. Scientists study the cosmic microwave background, the ancient radiation left over from the early universe to determine the large-scale geometry of space. So far, observations suggest that the observable universe is extremely close to flat. But flat doesn't necessarily mean the universe is infinite. And this is where things become much stranger. Imagine a video game world where you walk off the right side of the screen and suddenly appear on the left. You could keep traveling in one direction forever and eventually return to where you began. Such a universe could be finite, but have no obvious edge. There wouldn't necessarily be a wall at the end. There would simply be a particular geometry connecting space back to itself. So the universe could potentially be finite, without having a boundary. But there is another enormous problem. We can only observe the observable universe. That's the region of the cosmos whose light has had enough time to reach us since the beginning of the universe. Beyond that region, there could be vastly more universe, perhaps an enormous amount, perhaps infinitely more. We simply don't know. Think about standing on a beach and seeing only the horizon. The fact that you cannot see beyond the horizon doesn't mean the ocean ends there. Our observable universe is similar. The cosmic horizon limits what information can reach us. The universe beyond that horizon may contain countless galaxies that we will never be able to observe directly, and that creates an unsettling possibility. Perhaps the universe is vastly larger than anything we can ever see. Maybe what we call the universe is only a tiny visible patch of something much larger. There is also the question of whether the universe is truly infinite. If space is infinite, then there may be no edge and no center. There could be an unlimited amount of space extending forever. But if the universe is finite, what does its boundary look like? Does it have an edge? If it does, what would be beyond it? And if there is something beyond it, would that simply become more universe? These questions reveal something important. Human intuition was developed to understand objects on Earth. We understand boxes, rooms, mountains, oceans, but the geometry of the entire universe operates on a scale our everyday experience cannot prepare us for. And perhaps the most mysterious part is that the universe doesn't appear to have a special center. From our perspective, distant galaxies are moving away as space expands. But another galaxy billions of light years away, could make essentially the same observation. Each observer could feel as though everything else is moving away. There doesn't need to be one central point where the universe began. The expansion happens throughout space. So when you look into the night sky, you aren't simply looking at objects inside a gigantic container. You are looking at the universe itself. Space is part of the story. It can expand, it can curve, it can stretch, and its geometry determines how everything within it moves. But despite all our telescopes and measurements, one fundamental mystery remains. Is the universe infinite, or is it finite, but without an edge? Could space eventually connect back to itself? Could the observable universe be only a tiny fraction of something unimaginably larger? We don't yet know, and perhaps somewhere beyond the farthest galaxy we can ever observe, the true shape of the universe is waiting, not at the edge of space, but hidden in the geometry of space itself. Mystery number 7. Why does the universe exist? We've traveled across the universe. We've explored dark matter. We've confronted dark energy. We've wondered whether intelligent life exists somewhere among the stars. We've traveled back toward the beginning of time. We've entered the darkness of black holes. And we've questioned the shape of space itself. But now we arrive at a question that may be deeper than all of them. Why does the universe exist at all? Think about it. You exist. Earth exists. The sun exists. The galaxies exist. Space exists. Time exists. But why? Why is there something instead of nothing? It is easy to imagine nothing. No stars, no planets, no galaxies, no space, no time, no matter, no energy, nothing. And yet, that isn't what we observe. There is a universe, and somehow, we are inside it. Scientists can describe how the universe evolved. They can calculate how galaxies formed. They can study the first moments after the Big Bang. They can explain how stars are born and how they die. But explaining how the universe behaves is not necessarily the same as explaining why there is a universe in the first place. Perhaps the laws of physics somehow make a universe inevitable. Perhaps what we call nothing isn't actually possible. Maybe even the vacuum of space contains quantum fields and energy. Maybe universes can emerge naturally from deeper physical laws. But then another question appears. Where did those laws come from? Why these laws? Why these constants? Why does gravity have the strength it does? Why does light travel at the speed it does? Why does matter exist? Why does the universe have the particular structure that allows stars, planets, chemistry, and eventually life? Some scientists have explored the idea of a multiverse. Perhaps our universe is only one among countless universes. Each could potentially have different physical properties. If an enormous number of universes exist, perhaps it isn't surprising that at least one has conditions suitable for life. And we happen to live in that one. But this idea creates another mystery. If other universes exist, can we ever detect them? If they are permanently beyond observation, how could we prove they exist? And if we can't test the idea experimentally, where does physics end and speculation begin? There is another remarkable fact. The universe doesn't merely contain matter, it contains observers. Conscious beings capable of looking into the cosmos and asking questions about their own existence. Think about how strange that is. The atoms inside your body were forged through cosmic history. Many of the heavier elements in your body were created inside ancient stars. Those stars lived and died long before Earth existed. Their material eventually became planets, and eventually became living organisms, and eventually became you. In a very real sense, the universe has produced something capable of looking back at the universe. The cosmos is observing itself through us. But that still doesn't answer the deepest question. Why is there anything to observe? Maybe there is an answer we haven't discovered. Maybe future physics will reveal a deeper principle from which the universe naturally emerges. Maybe there was never a true state of nothing. Maybe existence is fundamental. Or perhaps the question itself is beyond what human language can properly express. We are creatures who evolved on one small planet around one ordinary star. Our brains evolved to understand survival, movement, food, danger, and our immediate surroundings. Yet somehow, those same brains can imagine billions of galaxies. We can calculate the age of the universe. We can detect light that traveled for billions of years. We can construct theories about black holes and the beginning of time. But there may always be a boundary beyond which human understanding struggles. And perhaps that's what makes the universe so extraordinary. Every answer seems to create another question. We discover dark matter and ask what it is. We discover dark energy and ask why it exists. We understand the Big Bang and ask what came before. We discover black holes and ask what happens to information. We measure the universe and ask what lies beyond what we can observe. And eventually, every path leads back to the same mystery. Why is there something rather than nothing? Maybe one day, humanity will discover the answer. Or maybe the universe will always keep this final secret. But there is something beautiful about that uncertainty. Because every time we look into the night sky, we are reminded that we don't live at the center of everything. We are a tiny species on a tiny planet, surrounded by an almost incomprehensible cosmos. And yet, we are capable of asking questions about it. Perhaps that is one of the greatest mysteries of all. The universe is enormous. Our lives are brief. But for a moment, the universe has become aware of itself. And it is asking, why am I here?